All right, so yes, during the process of cracking hydrocarbons, and something is converted into a something, the presence of something can be shown by a visible reaction with something else. Which words complete the gap 1, 2, 3, and 4? So during the process of cracking hydrocarbons, when we crack in hydrocarbons, we normally crack an alkane. So it's either A or B. C and D is out. Something is converted into something else, right? Alkane. So during the process of hydrocarbons, an alkane is converted into alkene. All right. Alkene is converted into alkene. And the presence of something can be shown by a visible reaction with something else. The presence of an alkene, so far it's A or B, can be shown by a visible reaction with, is it bromine or steam? I have one person saying B and somebody else saying A. Let's see what the answer is. The answer is A as in apple. All right, the answer is A as in apple. All right, C was the answer for this question, and A is the answer for this question. You realize that we're still talking about bromine. All right, so yes, you guys are correct. All right, if you had A as your answer, you were correct. Right? All right, good going, guys. I'm glad you're seeing it. All right, so next question. Which statement about alkenes is not correct? Right? Remember, the operative word here is not correct. Right? They highlighted for you. Not correct. All right? They are hydrocarbons. They are saturated. This one here it is. They are not saturated. Alkenes are unsaturated. All right? That is correct. They are unsaturated. So the answer is B. They are unsaturated. All right, next question. Which molecular structure shows hexene? Right? Which molecular structure shows hexene? 30 seconds, guys. Let me see who's going to come up with the answer. All right, you don't all have to rush. You don't have to rush. Yes, yes, yes. The answer is A. Right? How do we know that? B only have single bonds, so this is an alkane, so it cannot be B. C has an OH group, which means it's an alcohol, so it cannot be C. D has a C double bond or OH group, which means that this is an acid. It cannot be D. So that leaves us with A, which has a double bond. That tells us that we're dealing with an alkene. It has 1, 2, 3, 4, 5, 6 carbons. 6 represents hex. So we're dealing with hexene, right? Hence A is our answer. Let's see. Yes, A is our answer. Get going, guys. Next one. Which statement about alkenes is not correct? Which statements about alkenes is not correct? All right, so this one is getting a little interesting. All right, the functional group is carbon double bonded to carbon. That is correct. The structural difference between one member and the next member is a CH3 group, right? No, this is not correct. It's not a CH3 group. Yes, the answer is B, right? They form a homologous series. Yes, they form a homologous series. And they turn aqueous bromine from brown to colorless. Yes, they turn it from brown to colorless. So yes, that is correct, right? So the answer is B as in boy. B as in boy. That is the one that is not correct. So number 10, the answer is B. All right, number 11. The diagram shows a reaction sequence: butane, X, ethene, Y, ethanol, Z, carbon dioxide, and water. All right, and they're asking you which row names the processes X, Y, and Z. So to go from butane to butene, they're asking you what process is that? Do you think that is cracking or distillation? And you think back and you say, oh yes, we talk about cracking so much, so that answer is possibly cracking. So yes, B, the first one could most likely be A or B, which is cracking. All right, right? The first one is cracking. And then ethene going to ethanol, why? It means water is being added across it. If water is being added to something, it means we are hydrating it. When you finish run a marathon and you feel dehydrated, it's because you've lost a lot of water. So what they do, they give you water, Desani, right? Or blue waters, whichever one you prefer, and you hydrate. So that process going from ethene to ethanol, water is being added across the alkene, so that's hydration, which gives us B. And then from ethanol to carbon dioxide and water, anytime a substance undergoes combustion, it produces carbon dioxide and water. So combustion is our next reaction. So B is our answer. B as in boy is the correct answer. All right, so I hope I'm not going too fast for you guys. All right, number 12. Alkenes are manufactured by cracking hydrocarbons obtained from petroleum. Alkane X obtained from petroleum undergoes cracking and gives you alkene Y. So again, if we have an alkane, we are dealing with a large alkane because we get it from petroleum. We get it in its raw state. This undergoes cracking and it gives us an alkene. The alkene would most likely be a small substance. So therefore, it goes from large X to a small y, a larger alkene to give you a smaller alkene. Would they need a catalyst? Yes, they would need a catalyst to lower the amount of energy, but you would need high temperatures, 5, 6, 700 degrees Celsius for this reaction to happen. So your answer for this one would be B as in boy. B as in boy. Large X molecule, small Y molecule. Catalyst, yes, it would require a catalyst and high temperatures. Right? A would have been an option if they had temperatures high. If it was high instead of low, then A would have been the next best answer. Right? But because they put the temperature low, that cancels out A. For C, the size of X being small cancels out C, and the size of X being small cancels out D. All right. Next question. Yes, Dimitri, you have a question. Talk to me. A catalyst speeds up the reaction. Correct. The catalyst does speeds up the reaction. So can cracking takes place if a catalyst is not present? Yes. Right. It will just be seen as cracking. If a catalyst is present, then it is referred to as catalytic cracking, but it will just be slower. That is correct. That is correct. Right. So just for you guys who haven't seen the question that is being asked, right? If catalyst speeds up a reaction, can cracking take place without the presence of a catalyst, right? And the answer to that question is yes. If there's no catalyst present, the reaction can still take place, but it will just take a longer time for the reaction to take place, right? But it must happen at high temperatures. Okay, so next question, question 13. Thank you for that question. X, Y, and Z are three hydrocarbons, right? So X, something's missing from X. A hydrogen should be right here, right? So CH2, CH2, Y, CH3, CH, CH2, and Z, CH3, CH2, CH, CH2. They ask you, what does compound X, Y, and Z have in common? All right, so don't overthink it, guys. Don't overthink it at all. Ask yourself, what is present in all of them? They all have a double bond, right? They all have a double bond, right? That's the thing. They all have a double bond. So are they alkenes? Yes, they are all alkenes. The next question they ask, they are all part of the same homologous series. Yes, they are all part of the same homologous series because they are all alkenes. So 1 is correct, 2 is correct. They all have the same boiling point? No, they don't all have the same boiling points, right? Because one have more carbons than the other, one will have more bonds than the other. So therefore, it would require a lot more energy, right, to break, right? So they would have different boiling points, right? Bridgemorehan, good going, good going. All right, so yes, the answer is indeed B, 1 and 2 only, B as in boy, that is correct. All right, number 14. The diagram shows the cracking of substance X, right? So you would have seen something similar to this in the slides earlier, right? So you have cotton wool soaked in X. So X is most likely a alkane. The catalyst is most likely alumina, Al2O3. Okay, and the gas that is produced at Y is most likely a alkene, a hydrogen gas or a smaller alkene. So what type of organic compound is found in Y, which is not present in X? The alkene, right? The alkene. Acid? No, it wouldn't be an acid. We do not need acids yet. Alcohol? No, in order for us to get an alcohol, we need steam, water vapor, right? And we add that to the alkene to give us the alcohol. Alkane, alkane is at X. Alkene, the answer is D as in dog, right? D as in dog, the answer is D. So at X, you'll have the alkane, but at Y, you'll have the production of the alkene. All right, our answer is D as in dog. Okay, so I want you guys to think, yes, the answer is D, that is correct. All right, D as in dog. So the diagram shows some properties of two organic compounds, X and Y. Right? When you look at X, X reacts with bromine and it can also polymerize. So it can also produce polymerization and it reacts with bromine. X in the presence of steam and a catalyst produce Y. So if X could react with bromine, then X is most likely an alkene, because only alkenes can react with bromine to give you a colorless solution. And alkenes can undergo addition polymerization. So if the alkene reacts with steam, it will produce a catalyst, sorry, it will produce the alcohol. So Y is most likely an alcohol. Y is most likely an alcohol. And X is most likely a alkene. All right, so let's see what they're asking us now. What are X and Y? X and Y is D as in dog. That is correct. D as in dog. All right. Ethene is X and ethanol is Y. Right? D as in dog. All right. Yes, question. What type of fuel is ethanol used for? You could use ethanol in a flambeau. You could use it in a spirit lamp inside of laboratories. Anything that needs fire. However, it can vaporize very easily, right? Those are just two examples of the use of ethanol. So, for example, in a school laboratory, if you want to expose students to a small amount of flame, but you don't want to use a whole gas, tanker gas, you could pour some ethanol inside of a spirit lamp and you light the wick, right? So, you know, like when people die, right? And they want to remember them, they just put a substance inside of one of them rum bottle and then drop a little wick inside of it, and you end up with something like a little flambeau something, and they put down one by every house or every two houses on the side of the street, and they line the street with these bottles and they lighted a fire and they remain lit for all through the night, right? You could use ethanol as a fuel like that, right? That's just one example of a use of ethanol. Of course, there are other fuels that you could use as well, but that's one use of it, right? It could also be used as a purifier. So in biology labs, when you have slides that you want to clean, to put specimens on to look under a microscope, you can use ethanol after you wash the slide, right? You use ethanol and you light the ethanol and you dip the slide in the alcohol and you pass it over the flame, right? And it helps to clean the slide much cleaner than if you had used a tissue paper to clean it, right? That's another use of the ethanol. Ethanol, you could use it as a cleaning agent. So if you have a place that is dirty or contaminated, you can pour some ethanol on it and wipe it, and it will work. Another use of ethanol, your marker. Let's say the whiteboard marker is not functioning and it's running out of ink. You could open the back of the marker, pour some ethanol inside of it, and it will sustain the life of the marker, the whiteboard marker, right? That's just a messy process, and I just don't like to do that. That's why I don't reuse markers and stuff. But that is actually one use of ethanol. It can increase the lifespan of some of these things, right? Another thing, hand sanitizers. A lot of people are paying exorbitant amount of money for hand sanitizers, right? Yes, just now you get a break, right? A lot of people are paying a lot of money for hand sanitizers, but the hand sanitizer only have a small amount of alcohol, right? If you want to get a good hand sanitizer in this time, make sure and check the alcohol content in it, right? And ethanol is one of that. If you buy a hand sanitizer and it only have a small amount of alcohol, you can add ethanol to it to increase the alcohol content, which helps it to work well in sanitizing your hand and killing bacteria, right? So that's another good function of the alcohol. All right. I have a question for you guys. Yes, a chemist carried out a cracking reaction on a hydrocarbon X and obtained two products, Y and Z. So some hydrocarbon X was used to give us an alkane plus an alkene. The chemist then wrote the following statements in his notebook. A molecule X has 7 carbon atoms, Y is unsaturated, and Z will decolorize bromine, right? So Y is unsaturated. So Y is an alkene. Which statements are correct? If Y is an alkene, alkenes are saturated, not unsaturated. So this here is wrong. And Z will decolorize bromine. This is an alkene. Okay, so this is correct. A molecule of X has 7. Here, 1, 2, 3 carbons. 1, 2, 3, 4. 4 plus 3 is 7. So yes, X could have 7 carbons. So 1 and 3. So the answer is C as in cat. C is the answer I came up with. Let's see what they say the answer is. All right, and the answer is indeed C as in cat. Next question. Molecule X is both an alkene and a carboxylic acid. Which row describes X? If it is an alkene, then is it saturated? No, it's not saturated. It's unsaturated. And if it's an acid, then it will have the C double bond OH present, right? So the answer is indeed B as in boy. No, it's not saturated because it's unsaturated, and it is a carboxylic acid. So yes, it will have C double bond O, OH group present, right? It will have this functional group present, C double bond O, OH. Hence the answer is B as in boy. All right, 19. Alkenes have the general formula CnH2n. Which of the following is an alkene? So we can't have one carbon to give us an alkene. So A is out. All right. We cannot have one carbon to give us an alkene. So B is out. So that leaves us with C and D. So let me see you guys. What do you think is the answer? C or D? C is your answer, C3H6, because the formula is CnH2n. So if n is 6, then H2n will be 6 by 2. So this should have been 6 by 2 is 12. So it should be C6H12. So then this one is wrong, and that leaves the answer as C. So C is correct. Yes, C is the answer. Next question, question 20. The structure of a compound is shown below. All right, and in the compound we have C double bond O, OH, that's the functional group for acid. Then you have C double bond C, that's the functional group for alkene. There's no OH group, so you have no alcohol, and it's not only single bond, so it's not an alkane. All right, so question, what functional groups are present in this compound? There are no alcohols present, so A is not your answer, B is not your answer, so it's possibly C or D. Next thing, they tell us, do we have an alkene group present? Do we have a double bond? Yes, we have a double bond. And do we have a carboxylic acid group present? Yes. So our answer is C as in cat. All right, our answer is indeed C as in cat. All right. Next question. Question 21. When a long chain hydrocarbon is cracked, the following products are produced. All right, so you have 1, 2, 3, 4 different products that are produced, and they're asking you the question, which product decolorizes bromine? So we are looking for alkene that would decolorize bromine. So anything that is an alkane is out, right? So C3H8 is an alkane, right? Because this is CnH2n plus 2. So this one is out. C3H8 is out. C2H4, this is possible. C3H6, this is possible. C2H6, this is an alkane, so this is out. How do I know it's an alkane? If C is N, so C is 2, H 2 by 2 plus 2. 2 2s are 4 and 2 is 6. So this has the formula of an alkane. So this is out. So that leaves us with 2 and 3 as the answer. So the answer is B as in boy. All right, B as in boy is our answer. All right, 22. Right, the diagram shows the structure of a compound, and they show us the compound. Right, so the first thing I'm going to look for is the functional groups in it. I have a double bond here, C double bond C, and then I have a OH group here. So I have an alkene present, an alcohol present. So if there's that, then there's no alkenes. All right, so let's see what there's no acids. Okay, so when you have alkene and alcohol. So let's see what the question asks. To which classes of compounds does this molecule belong? Alkanes, no. So A is out and B is out. No, A and B is actually correct because they have no alkanes. So C is out and D is out. There are no alkanes. So it's either A or B. And for alkenes, there is a double bond present. So yes, there is a double bond present. And yes, there's a OH group present. So the answer for this one is B, as in boy. Right? So there are no alkanes. Alkenes, yes, an alkene is present, and yes, the alcohol is present. So the answer is B, as in boy. All right. So which structure is correct? So to show you 4 different structures, I want you to take a careful look at this one. This is a tricky one. And I want you to tell me what you think is correct. Which one you think is incorrect from this. All right. Yes, C is incorrect. And the reason why, carbon is tetravalent. So each carbon is supposed to be bonded only to 4 other bonds. If you look carefully at this one and see here, you have 1, 2 bonds, 3, 4, 5 bonds to each carbon. If you check carefully, you have 1, 2, 3, 4, 5 bonds. And carbon can only have 4 bonds each. Right? So A is correct because each carbon only have 4 bonds, right? Each carbon only have 4 bonds. B is correct. C is wrong, and D is correct. So the answer, that the one that is incorrect, is C, as in cat. That one is incorrect. All right. So the next question. The apparatus shows an experiment used to test gas X. So gas X is a gas that we're putting in. All right. It's bubble, and there's an orange bromine or orange brown bromine solution that is inside of here. Don't mind, mine's not looking orange. They tell you the bromine solution quickly becomes colorless. So my question to you, which structure, A, B, C, or D, is responsible for that bromine going to colorless? All right, so let me see what answers you're coming up with. A, B, C, or D. I have one person saying B. Anybody else saying B? Anybody think it's A, C, or D? Going once. I have one person saying C. All right. I have a next person saying B. Okay. Anybody want to change and go B? 2 saying B, 1 saying C. Going once. Going twice. All right. So here it is. I have 2 saying C. All right. All right. All right. So yes, now it's even. 2 people think the answer is C, and 2 people think the answer is B. All right. Anybody else? Anybody else want to break this tie? One more, one more. One more. Anyone? All right, so let's see how this goes. If we have a gas and the gas is changing bromine from an orange bromine solution to colorless alkenes, forgive my handwriting, right? I write it with my finger. Alkenes are responsible for bromine water changing color. Alkanes cannot change bromine water from orange to colorless. Alcohols cannot change bromine water from orange to colorless. So A is an alkane because there are no double bonds present. So A is out. B has a double bond, so B is possible. C has no double bonds, so therefore it's not an alkene, it's an alkane. D has a OH group, it's not an alkane, it's not an alkene, it is an alcohol. So that leaves us with the option as B, as in boy, because of the presence of the double bond. The bromine causes the double bond to break, right? That double bond across the carbon breaks, and it becomes single bonds, right? The double bond across the carbon breaks and it becomes single bonds. So when this bond breaks, one can come here, one part can come here, and we'll have the formation of a halogenoalkane because bromine will be added across the double bond. Right? So that makes B the correct answer. All right. So let's move on. Okay, so I just give you some multiple choice questions. All right. I'll also send that to you guys as well. Next question. Petroleum is a source of many important chemicals, right? Name 2 industrial processes which must take place to produce alkenes from petroleum, right? And those 2 processes, in order for us to get alkenes, there are 2 and only 2 ways by which we can get the alkenes from petroleum. One is fractional distillation and the other is cracking. It could be cracking with a catalyst or cracking without a catalyst. Next question. Ethene, CH2, double bond CH2, and propene, CH2, double bond CH3, can both be converted into polymers. What type of polymerization takes place when ethene forms a polymer? Let's go back. An alkene, when it forms a polymer, it can only happen by addition polymerization. When an alkene forms a polymer, it can only happen by addition polymerization. Because there's a double bond, the bond can break and hydrogen could be added across the double bond. Something could be added across the double bond. With alkenes, the type of polymerization that we can have is addition polymerization. Now, they say, what is the empirical formula of the polymer formed from ethene? So ethene has the formula C2H4, right? Et because we have 2 carbons, ene because there's a double bond present, right? So they ask, you know, what is the empirical formula? The empirical formula is the simplest whole number ratio of carbons to hydrogens. So if we were to break this down, we could say 2 into 2, 1, and 2 into 4, 2. Hence, we end up with C1H2 or CH2. Right? The next one, propene has the structural formula CH2 double bond CH3. Draw 2 repeated units of the polymer made from propene. Now, if you look at this structure closely, you'd see that this is 1 repeated unit and this is another repeated unit. So you have CH2 and then there's another carbon bonded to it. Now the double bond is broken and on one side we have hydrogen and on the next side we would have CH3. Right? This is the unit that is being repeated. CH2, CH2, right? And then CH3, right? They put this one first and the next one after. It doesn't matter which direction you had put it. All right, if you had put the CH and then CH3, or if you had put that one first and then the other one after, that doesn't matter as long as you show that repeated unit. Right? So the polymer is made from the monomer. So the polypropene that would be formed from the propane.